So let's say, sir, your A is equals to 3 and your B is equals to 6. So we know this thing, when I'm going to divide my 6, when I'm going to divide my number, it will always give me an integer division. That means if 25 is getting divided by 2, I'm getting 12. So what about that extra A which I'm having? Am I making sense? Who was that guy who asked me this question? Sir,
Yes, yes.
so Akash, uh, when I'm dividing my 25 with 2, I'm getting 12. Where's that extra A? I'll have to tackle that also, no? Am I making sense? And the reason of dividing B with 2, because I know this thing, every time I'm updating my A with A into A. So one of the A has been taken extra, right? So in short, if my B is 4 and I'm updating my A with A into A, can I say this thing? My B will get exactly half if A will be multiplied with A. Am I making sense, Akash?
Yes, yes.
So basically, Akash bhai, A is getting updated with A into A. So every time I'm taking two of the powers from B. So for this reason, I'm keep dividing my B with 2. That's it. Make sense, Akash?
Yes, sir.
Okay, fine. So I think we have discussed some sort of, I think, number theory. By the way, are you guys free on Saturday and Sunday? Can we take a test on HackerRank? I think that would be a time bounded test. I think for 1 hour, right? And we'll be giving you three questions, and you have to solve those three questions. And those three questions will be from the syllabus only, the things which we have discussed till now. Can I expect a thumbs up for that? And if there will be someone who will be having any sort of issues, no worries for that. It's okay. Fine. So we are done with the number theory and we're done with the linear search. Fine. Now we are going to cover another searching algorithm. But if I have linear search, then why I'm going with another searching algorithm? Fine. So for that, I have an optimal searching algorithm, and that is my binary search. That's it. So is there anyone who has any sort of knowledge regarding binary search can unmute himself or herself and tell me that? What is a binary search and why it's being used? That's it. Anyone? Akash, Ritvika, Mohan, anyone?
Yeah, Nitin. Can you hear me?
Yeah, I can.
Yeah. In linear search, we are iterating through each of the element to find the target pair. Target.
Mm-hmm.
So
Mm-hmm.
in binary search, what we will do is for the we to reduce our time complexity, we will divide our elements into half and
Mm-hmm.
check whether the target in the middle element if it is greater or not, so that we can if it is greater we take the other off, if it is less we take the first
Okay,
off.
okay, I got that. I
Like that
got that.
we can
So you're
get the
explaining me the
login.
algorithm. Hemant bhai, you're explaining me the algorithm. I'm just asking about the word binary search means. That's it. Why there is binary word here? What's the purpose of that?
Binary means maybe two options every time we are dividing two parts, right? So we take as a binary.
All right. See here.
Yeah.
Yeah. So let's just break these two words. So binary simply means 0 and 1. And if we are a traditional programmers, so for us, 0 is being treated as false and 1 will be treated as true. That means you are writing an algorithm, and in that algorithm, every time you have to choose a part which will be true and neglect that part which is false. I'm repeating once again. Binary search simply means searching in an optimal way and selecting one of the part of my array which will be true, and the other part will be neglected because that part is false. So why binary search, how binary search, and why and what is binary search? So let's start with what is binary search. So it's an optimal searching algorithm that means it is optimal searching algorithm. That means the linear search was taking big O of n time complexity, but this searching algorithm will be taking some time which will be less than big O of n. So the time complexity of binary search is big O of log n. Fine, let's start. So the question is, sir, how will we be able to recognize this thing that I have to use binary search in this particular question? Like, how would I get to know this thing? So we were talking about the patterns of data structures the moment when we have started this whole thing. Fine. So what is the pattern, sir? How will I recognize the pattern which follows the binary search algorithm? So the patterns are, please keep this thing in your mind. If there is any question and in that question it's been mentioned that the data structure or the array is shorted, that means the input which has been given to you is shorted. Second, if in the question itself it's been written that you have to write an algorithm which takes big O of log n time complexity. So there is only one searching algorithm which works on shorted array and which also takes big O of log n time complexity. So these two are the keywords of binary search. So this is one of the pattern of data structures. If your data is shorted and the time complexity which the question asks to you should be big O of log n, in that particular case, you won't be thinking about any other approach. You will be solving that question by using binary search. Again, there would be some sort of questions in that you won't be getting shorted array. In that also, you will gonna use binary search because the algorithm is being shifted towards only one thing, but that algorithm would be used after having some tiny manipulations. That means by performing some tiny manipulations, you can use that algorithm to solve some complex problems. But the algorithm is being derived from binary search, so it will still be called I'm using binary search in this question. In short, the keywords are shorted, the array should be shorted, the data structure should be shorted. First, second, if in the question itself it's been written that you have to write an algorithm which takes big O of log n time complexity, you will gonna use binary search in that question. That's it. So from today onwards, if you will be seeing any restriction towards time complexity and that is big O of log n, you will gonna use binary search in that question. That's it. You won't be solving that question with any other approach. So what is binary search? We have covered that. Second, how to use binary search. So for that, I have just told you that the array will be sorted, the data structure will be sorted. So let's say, let's take an array and this array is sorted. Sorted means the data elements will be in ascending or descending order. So in 95% of situations on lead code, you will gonna find the elements in ascending order. That is, I have 2, I have 4, I have 6, I have 8, and I have 10. So this array is sorted in ascending order. So one of the condition of binary search is fulfilled, that I got an array which is sorted. Second, this whole thing is a two pointer approach. That means you will be always taking two pointers, two variables to denote the initial point of your searching and the final point of your searching. So what we have to do, we will be taking a low pointer, and this low pointer will be at the zeroth index of your array. And you'll be taking a high pointer which will be at the last index of your array. And every time you will be calculating the middle value. And what is the middle value? Low plus high by 2. So let me take a variable named middle, that is low plus high by 2, and that will give me the middle value in every iteration. And what I have to do, I have to make the total iterations until my low pointer is less than or equals to the high pointer. So the thing is, the initial pointer cannot be more than the final pointer. Man, you tell me one thing. The initial distance, can it be more than the final distance? If you have to cover 10 kilometers, so the next distance is 10 kilometers ahead from you. That means that distance will always be in plus to you. That means your low pointer should be always less than or equals to high pointer. So we did three things in total. We have taken two pointers. The first pointer is my low pointer, which is at the zeroth index of my array. And the second pointer is the high pointer, which is at the last index of my array. And I will be calculating the middle index, low plus high by 2. And now I have to specify the target. So let's say I have to search for 4. I'll have to search the index of 4 in my array. So let's start with that. So I have calculated the first mid. So mid will be equal to 0 plus last index 1, 2, 3, 4 by 2, and it will give me 2. Fine. So the first middle index which I got is 2. Now what will I do? I will check the element which is at my middle index. Is it equals to my target? Let's check for that. That means the element which is at the middle index, is it equals to your target? So if I have an array, so I will gonna check if array of mid is equals to target. That simply means if the element which is at the middle index is the same element which I was searching for, then that's my answer. This middle is my answer. That means return this mid value. Otherwise, there are two conditions. The first condition is if the element which is at your middle index is greater than the element which you are searching for. Now tell me one thing. Let's say your middle index is 6. Your middle index is 6 and you're searching for 10. Now tell me one thing. The whole array is sorted, and to search 10, I have 6 in middle. So can I say this thing? I have to go in the right direction of my array. Give me a thumbs up if I'm clear on this. If the target is greater than your mid, that simply means I would be getting greater value in the right part of my array. And if your mid is, let's say you are searching for 4 and your middle is at 7, that means you will be needing a lesser value in next iteration. And to get the lesser value, you have to move in the left part of your array. So if your middle element is greater than your target, that means you are needing a lesser value. So the lesser value will be in the left part of your array. And if your mid is less than target, that means in the next iteration, you would be needing a greater value, and the greater value will lie in the right part of your array. So if your mid is greater than target, that means your answer is low, less than your mid. That means you have to move in the left part of your array. So to move in the left part, your high was here. Now what you will gonna do, you will put your high at mid minus 1. And in this particular portion, you will search if your mid is greater than target. But what if the element which is at the mid index is less than the target? That means the element which I'm searching for is greater than my current mid. That means in the next iteration, I would be needing a greater value. And to get a greater value, I'll have to move in the right part of my mid. So I'll gonna put low pointer at mid plus 1. And in this particular reason, I'll perform searching. So what is binary search? Binary search simply means to move in the left part or the right part of array in spite of thinking where my answer would lie. We just have to follow the concept of sorting. If my whole array is sorted and I would be needing a greater value, I will be moving in the right part of my array. And to move in the right part of my array, low will be equals to mid plus 1. And to move in the left part of my array, my high will be equals to mid minus 1. That's it. And the moment when your middle index is the element which is at your middle index, if it is equals to your target, in that particular situation, your mid is the answer. So you will gonna return mid as an answer. Guys, give me a thumbs up if I'm clear on this, because I'll dry run also. I'll be taking another array and I'll dry run the whole code for you. Give me a thumbs up, or if there is any doubt, please ask. Yeah,
Will
Chini.
you please explain it again?
I'm taking one more array. I'll dry run I'll dry run for you, right?
Okay, okay, fine.
Yeah. This is my array. And what I have to do, I have to find target, and my target is 15. I have to find the index of 15, which is 0, 1, 2, 3, 4. 4 ही है ना? 0, 1, 2, 3, 4. Right? So my answer should be 4. So what I'll do, the initial pointers will be low, which is at the 0th index of my array, and the end pointer will be at initially it will be at the last index of my array, that is array dot length minus 1. And I'm moving my low ahead and high to backward. In that situation, there would be a condition where my low is greater than high. So what I have to write, I have to write a condition, and that is my low should be always less than or equals to high. So this is my while loop. And in that while loop, I'll be writing a condition that my low should be greater, less than or equals to high. The first condition is if, just a minute. So the very first thing which we have to do, we have to find the middle index every time. So middle will be equals to low plus high by 2. So initially your low pointer is at the 0th index and the high pointer is at 0, 1, 2, 3, 4, 5, 6. So your low is 0 and your high is 6. The first middle value will be 3. That simply means now you will check, is the element which is at the middle index, is it equals to your target? Let's see that. Is your 3 equals to 15? Yes or no? Is your 3 equals to 15? Not 3, man. Middle
No.
will give you the index. So the element which is at the third index, 0, 1, 2, 3. So 10 is at the third index. Is your 10 equals to 15?
No.
Is your 10 equals to 15? No. That means now you will gonna check, is your middle element is greater than 15 or it is less than 15. So 10 is great less than 15. That means in the next iteration I'll be needing a greater value. So the greater value will always lie in the right part of your 10. So you won't be searching in this particular section. Now you will gonna search in this particular section. Now, so to move in this particular section, your low was initially at 2. Now your low will be at mid plus 1. That is from here. And you're gonna search in this particular portion. Again, low plus low plus high by 2. The next mid will be low plus high by 2. So now your low is at 0, 1, 2, 3, 4. Your low is at 4 and your high is at 6. The next middle value will be 5. 4 plus 6 by 2 will be 5. 0, 1, 2, 3, 4, 5. So the middle value which you got is 18 and the index is 5. Now you will gonna compare, is 18 equals to your 15? No, it's not. Is 18 greater than your 15? Yes, it is. That means in the next iteration, I'll be needing a lesser value of 18. So to move to get the lesser value, I'll be moving in the left part of my array. So your high will be, so your high was here initially. Your high will be mid minus 1. High will be equals to mid minus 1. Your current mid is 5 and where is that? Your current mid is 5 and the next high will become 5 minus 4. That is 4. So now your low is 4. Your high is also 4. The next middle value will be 4 plus 4 by 2 and that is 4. And now if you'll notice one thing, the element which is at the middle index 0, 1, 2, 3, 4 and that is 15 only. So the element which is at the middle index is equals to the element which is the target element. So at last you will gonna return the value of your current mid and 4 is your answer. Guys, am I clear with that? Chini, Akash, Hemant, am I clear with that? Should I have to dry run it once again? Is it needed? Anyone who wants me to dry run it again with another test case, please raise your hand.
1 4 got from high minus 1. Another 4 from where we got that.
Uh, Another 4. Man, your low was 4, na? You made your high mid minus 1. So mid
Yeah,
was 5. So it becomes 4. Your low was
yeah.
initially 4.
Okay, okay.
Yeah. Take 2 minutes and try to dry run. I'm giving you an input, right?
Okay.
And you have to search 18, the index of 18. Start. Take 2 minutes. Take 5 minutes and try to dry run it. And one of you will share your screen and will explain me the concept of binary search. Dry run it. I just want to see your screen how you have dry run. That's it. Take your time. Uh, is there anyone who's done with the dry run?
Yeah, yes, Nitin.
Hemant, will you be able to share your screen for me?
Yeah, yeah.
Okay, thank you.
Can you see my screen?
Just a second. Yeah, I can.
Yeah,
Okay.
our target is 18, right? So
Mm-hmm.
I divided, first I counted, there are eight elements. So
Okay.
in the first step, I divided it by 2, it's a 4. In the
Mm-hmm.
fourth index, we have 14.
Mm-hmm.
So I checked if 14 is less than or greater than, it is very less
Just
than.
a second, just a second, just a second. Where's that low and high pointer?
Uh, Basically, it's very hard to write, so I thought uh,
You'll have to
I'm
go with
using.
that low and high pointer, na?
Oh, yeah, yeah, yes, yes.
Where's that?
Basically,
Mm-hmm.
it's difficult to write here in the paint
Okay, okay,
with
fine,
the
fine.
mouse, so
So,
I didn't wrote.
so low is 0 and high is 7. So 0 plus 7 by
7,
2
yeah,
will be 3.
yeah, yeah, yes, yes. Okay, okay.
Got your mistake.
Yeah, yes, yes, yes.
So it will be 3 and the element will be 12.
Yeah, here. Okay.
And 12 is less than 18. So that means I would be needing a bigger value in the next iteration. So low will be equals to mid plus 1.
From 8, 4, right?
Yeah.
Mid plus 1 from 4. Then 7 minus 4 by 2.
Then 7 plus 4 by 2. That will give me 5.
7. This element.
16. Yeah.
See, 16. Yeah. Then we will check it is less.
16 is
So
also
then,
less than 18. Yeah.
this will be the low point. This
Okay.
will
Okay.
be the high
Okay.
point.
Okay. Yeah. Got that.
Yes.
So low is 6 and high is 7. 7 plus 6 by 2
7.
will give me 6.
6. Then we can find the element.
Okay. Okay. Fine. Very good. Very good. Very good, man. Anyone else who's having any confusion with the algorithm of binary search? Anyone? Should I write the code for you? How many of you wants me to write the code for you? Yes. Okay, fine. Which language should I choose? Should I go with CPP, Java, or Python?
I thought.
Okay, fine. Where's my pen? यार where I kept my pen. Okay. CPP, CPP. Okay, I think it's language independent, man. I think I have explained you the logic right. So now you will be able to write the code by yourself. Okay, Nitin bhaiya. No, man. Take 5 minutes and try to write the code. And if you'll be having any error, I will help you in every other language, whether it's Python, C++, or Java. Try to write the code by yourself. Take 5 minutes. Otherwise, I'll be starting with the code now. Should I give you 5 minutes to write the code? Hemant, Akash, Ritvik, Arnav. Should I give you 5 minutes to write the code? Simi, yes or no? फट से बताओ. Okay, take 5 minutes and try to write the code. And if you'll be having any error, just show me that in the moment. Let's learn together. Guys, I have shared one question in the chat box. It's the same binary search only. Fine. You just have to write the code for that. So if you're writing code, just try to write that code on lead code only. Fine. If you'll be having an error, any error, I will gonna fix that for you. Open this link and try to write the code on this platform only. Yeah. Is there anyone who's done with the code? Anyone? किसी का हुआ code? Just raise your hand if you're done with the code. अच्छा, take some more time. Yeah, Hemant. Are you done with the code?
Yeah, yes,
Just
Nitin.
share me, just share your screen to me.
Yeah, yeah. Nitin, can you see my screen?
Yes, Hemant, I can. Else,
Yeah,
else nums of middle is less than target. Math dot flow accepted. Math dot float max point.
Uh, Here I'm finding midpoint with max and midpoints every time, as we discussed.
Max point is minimum point. And if you're not able to find the that value, so at the end you'll be fine.
I'm returning.
So it's done. Yeah, hey Bharti. Okay, very good man. Hemant. Bharti, can you share your
Yeah,
screen?
thanks.
Yes, sir, I'm sure. So is it visible to you?
Yes, Bharti, it is.
So this is the
While
code.
lower, acha in Java only, less than or equals to high, nums of mid
Yes,
target,
sir.
nums of mid is less than target, and else high is equals to mid minus 1. That's great. So what would be the time complexity of this approach?
So it will be big of login.
We go of logging. Anyone else who's having any issue with the code? Anyone else? जिसका कोड हो गया है? Anyone else? Just raise your hand if you're done with the code. पलक हो गया आपका? Speak. Palak, are you done with the code? I'm not able to hear you. Write it in the chat box. Anyone else who's done with the code? Ritvik, Arnav, Palak, Mohit. Yes, sir, हो गया. What about Ritvik, Shikha, Shraddha, Shrutika? Are you guys done with the code? At least speak, guys. Are you guys done with the code? Should I show you? Yeah, Mohit, show me. Yeah, Mohit, share your screen.
Yes, sir, is it visible?
Yes, Mohit, it is. C++. Okay, fine. So the person who has written in JavaScript, just share the code in the chat box. And the person who has written in Java, share the code. And the person who has written in C++, share the code. Yeah, Ritvik. So basically, Ritvik, the thing is, on lead code, you don't have to write the main function. So what is a main function? A function where the execution starts, right? So the thing which you have written will only be executed if you have written those things in main function. Fine. So on lead code, you don't have main function. You just have a function in which you have to write the logic, and you'll have to write in such a way if that function would be called in a main function, you will be getting an output. So on lead code, you don't have main function, just a function in which you have to write the logic. That's it. Am I clear, Ritvik? Ritvik Bhati, am I clear? Yeah. So main function is already there in the backend. You don't have to write the main function. The function which has been given to you, you just have to write the logic in that. That's it. Okay. Anyone else who's having any issue with the code? You guys, please share the code. JavaScript, C++, and C, I think Java. Just share the code in the chat box. चल ठीक है. Let me update that doc. So I'll be adding some more questions of binary search in that doc. By the way, are you guys asking for your doubts with Shankar? Is there anyone who have asked anything who hasn't been in touch with Shankar? Are you guys asking doubts with Shankar? Say me yes or no, please. It's important for me. Are you guys asking your doubts to Shankar? Not yet, sir. No. Please ask, man. That guy is there for you. Please do questions and ask. Fine. And I'll be adding some more questions. I think there are in total 20 questions from binary search, and we'll be solving those 20 questions of binary search in the classroom as well. Fine. Palak, you can ask anytime, man. Before 10 p.m., you can ask anytime. Okay, so guys, that's all for today. And we'll be starting with a modified binary search and some questions which are being in the pattern of binary search. Right?
Oh, sir, I have one
Yeah,
question.
Bharti, go ahead.
Sir, as you said, you will add 20 questions. So that 20 question you will add in that time complexity doc, or you will be add one more doc
So,
in
Bharti,
classroom.
the thing is, ki, let's say I have added 20 questions, right? So, I'll be solving top 5 to 6 questions of those 20 questions. Am I making sense? So,
No,
yeah.
sir, that is not my doubt. Sir,
Mm-hmm.
actually, those updates which you are doing in time complexity doc
Mm-hmm.
file, that is not visible for
I don't
me.
know why. Give me a moment. So this is that sheet, fine. I'm sharing you the link. I don't know what's the issue. Bharti, can you please open this link for me?
Uh, yes, sir.
And Nitin, actually, what is happening if we directly open this link, it is visible. But when we go through the classroom, it is
Give
not
me a
visible.
moment. I'm
In
just
the
Achha,
link,
Hemant, can you do one thing? Can you do
yeah,
one thing for me? Copy this link and just paste it
yeah,
in that WhatsApp group.
yeah, sure, sure.
Bharti, is it fine now?
Yes. Yes, sir, it
Okay,
is fine.
fine. So I'll be adding some more questions with the lead code number in that sheet, right? That's it. So that's all for today. And you'll be getting recording by midnight only. Sometimes I got late because of processing speed, but I'll try my best to give you the recording by the midnight. Fine. And thank you so much for joining and have a beautiful day. Good night.